All right, section 11-1, space figures and cross sections. Okay, complete each statement with the correct word from the list. So a blank is a segment that is formed by the intersection of two faces. An edge is formed. A blank is a point where two or more edges intersect, a vertex. A cube has 8 vertices. A cube has 12 edges. All right, vocabulary. So a polyhedron is a space figure or a three-dimensional figure whose surfaces are polygons. The word polyhedron combines the Greek prefix poly, meaning many, and hedron, meaning base. So some examples are a prism or a pyramid. Some non-examples would be a circle, a cylinder, or a sphere. So cross out the figure that is not a polyhedron, and the figure that is not is this, that is a cylinder. All right, so how many vertices, edges, and faces are in a polyhedron at the right? So first identify the description of a vertex, an edge, or a face. So a point where 3 or more edges intersect is called a vertex. Okay. A polygon is a face, and a segment where 2 or more faces intersect is an edge. So the vertices are going to be R, S, T, U, V, and W. The edges are going to be RS, VW, RU, RV, ST, SW, TU, TW, and UV. The faces, quadrilateral RSTU, quadrilateral RSWV, and quadrilateral TUVW, and then triangle STW and triangle RUV. So the polygon has 6 vertices, 9 edges, and 5 faces. So we could sit there and always count these out. But you notice how kind of long that took there? There's actually a cool theorem that helps us do this. This is called Euler's formula. So the sum of the number of faces, F, and the number of vertices, V, of a polyhedron is 2 more than the number of edges. So here's a very important formula. F plus V equals E plus 2. So I can use that to find some justification. So Euler's formula is used to find the number of faces for a polyhedron with 30 edges and 20 vertices. So all I have to do is use the formula F plus V equals E plus 2. So if we know we have 20 vertices and we have 30 edges, I substitute those in, and I have 20 and 32 here, and then I subtract, and I have there are going to be 12 faces in this figure to the right. So a polygon with 30 edges and 20 vertices will have 12 faces. Okay. So using the solid as right, how can I verify Euler's formula, F plus V equals E plus 2 for the solid? So we could count the number of vertices. So there are 4 on the bottom, there are 4 on the top, and there are 8 total vertices. Bases, there are 2 bases, and there are 4 lateral faces with a total of 6 faces. Edges, there are 9 solid edges, 3 dashed figures, and 12 edges total. So now let's plug that in. Does 6 plus 8 equal 12 plus 2? Does 14 equal 14? Yep. All right, so let's describe a cross-section. For the solid I write, what is a cross-section formed by a horizontal plane? So a horizontal plane is parallel to the bottom of a solid. A view from the top of the solid helps you see the shape of the cross-section. So the cross-section would be a circle. All right. So a horizontal plane is parallel to which face of the cube? The top and the bottom. So circle the diagram that shows the intersection of a horizontal plane. This one. Okay. So use a cube to draw the shape of the cross section. All right. So we would draw it like this, and it would come this way, and it would go across the back, and it would come this way, and it would shade in this little area, So this would be the cross section. Okay, so the cross section is a square. All right. So suppose you had to build a polyhedron from 2 octagons and 8 squares. Without using Euler's formula, how many edges does this solid have? All right, so we know that the octagon and squares are the faces. An edge is a segment formed by the intersection of 2 faces. So to find the number of edges without using Euler's formula. Okay, so the intersection of the squares and the top of the octagon form 8 edges. The intersection of the squares and the bottom of the octagon form 8 edges. The intersections of the 8 squares form 8 edges. So the solid has 8 plus 8 plus 8, or 24 edges. And that's the end of this section.